We are here today to talk a bit about what's new in the 51 open source project, and in particular, the latest release, and that's 0.18. So without any further ado, who am I? I'm the co-founder and CTO at Voxel 51. And an important disclaimer, like I already mentioned, this is open source. And so everything we're talking about is available to you if you just go to your terminal and type pip install 51, maybe throw an upgrade in there if you've already used an older version of the project. Highly recommend upgrading because as you'll see in a bit, there's a lot of exciting enhancements that just came out in this latest release. Like I mentioned, it's open source, and so if you're feeling so inclined, would really appreciate a star on the project to show your support. And just a quick aside for why the 51 project was created in the first place, and that is that visual data is it contains a ton of information, but if you don't actually pull up those samples and look at them and understand the data that you have, the annotation that you're generating, the model predictions that you're getting, you really don't understand the performance of your model. And the reality studies show is that, while you might think that the large majority of developing a computer vision model is centered around what model should I use, how should I train the model, and so on, the reality is that a majority of your time as a data scientist or ML engineer is really spent on data. And as data sets continue to increase in size, that proportion's only going to increase. And so what we're going to try to help you do is understand what's in your data and how you can improve the quality of your data sets. And just a quick aside on why data quality matters. Well, if you have low quality data, you'll have low quality models, and those outputs have real issues. If you're working on customer or consumer data, you could have model bias issues that are going to make that model unusable. If you're developing systems for physical objects in the real world, of course, a bad model leads to bad outcomes for humans. And just to translate that into a quantitative number, if you're training models on low quality data sets, you're going to see a massive decrease in your model's performance, but it may not be the reason you expect. We did a study, for example, on the Google's Open Images data set, where we found that training a state-of-the-art model on the state-of-the-art data set, something like 30% of the so-called issues in the model on evaluation weren't the model's fault at all. It was the fault of the data set. So if you train on incorrect data, your model will learn incorrect things. And the key to addressing those issues is to get hands-on with your data and improve the quality of those data sets. That's why our company exists. We're focused on improving the transparency and clarity of your data. And we think that the right way to do that is to allow you to build data-centric workflows where you develop your data sets and your models side by side. That's what the 51 project's all about. Again, everything's open source, I'm going to show here. So the project in general is designed to help give you a way to organize your data sets through code, but then also visualize them through an application that allows you to index, search, query your data sets, run workflows like annotation, analysis, integrations with annotation vendors, with the goal of helping you pull everything you know about your data sets and your models into one place, and giving you tools to help find and address issues in the annotations, your model predictions, and again, iterate on your data sets. So all kinds of goodies in the documentation. We'll still show that a bit later. But in general, 51, you should think of it as a tool that helps bring your data-centric part of your world, like the way you get your data annotated, the way you find your data, the places you store it, together with your model-centric tools, the way that you train your models, the frameworks that you use, the tools that you use to track your experiments. 51 brings those two together and helps you iterate on your data sets and models together. So what is 51 meant for? Well, it's meant for all things computer vision. So it supports things like classification, detection, segmentation, polylines, and key points, both on image video as well as 3D. So recently we added support for 3D point clouds, 3D object detection, and so forth. You can see that up here. And as well as other capabilities like geolocation and working with embeddings of your data. So not just looking at the pixels of the images, but understanding how they relate to each other in an embedding space to help you run workflows like finding outliers or patterns in your data sets. All interesting stuff you can do through open source 51. It's got a very powerful API that's designed to help you organize your data and query it. In fact, a recent blog post came out comparing the way that you could filter your data in FiftyOne to the way that you may do so with tabular data in Pandas. So one analogy to think of is that FiftyOne can be for you a Pandas for computer vision. And the documentation outlines that in great detail, showing how you can write common searches and organize your data and so forth. Definitely recommend checking that out. And then the perhaps more interesting part of the tool is how do you actually automate or otherwise find these mistakes that you think may exist in your data sets or in your models? That's an area of the tool called the brain. So with the brain, you'll find workflows for identifying model failures, whether that means running evaluation and then doing a simple query to show the samples where the most false positives exist as an example, or using embedding-based workflows to find patterns in your data or identify visually similar characteristics that may exist in areas where your model is not performing well, or maybe mining new samples from your data lake to address those issues. All of those concepts, those are the workflows are available in the part of the tool called the brain for that. Not the topic of today's discussion, but just wanted to point it out because it's an important way to help you actionalize what happens when you found an issue. How do you take action on it? How do you improve the quality of your data? So with that said, let's dive into what is new in the latest release, 0.18. So quick highlights, significant improvements in performance in the app. So if you're loading large data sets with many fields and or many samples, you'll see, as I'll show in a bit, that the app loads much faster. Big improvement. It's of utmost priority to us to make it as fast as possible for as large of data sets as possible. And big strides were made in this release towards that goal. Underlying that or enabling that performance improvement was a concept called sidebar modes that we'll get into in a second. And with those two, we were also able to add support for custom label attributes to your data sets. So not only can you filter by default attributes like the label and the confidence of a classification or detection, you can now declare and filter by custom attributes on your data sets, as I'll show later. You can also add metadata about your fields. For example, you could describe what the architecture of the model is or link to your experiment tracking dashboard where that model came from. You can now store that information in FiftyOne and visualize it in the app. There's a cool new light mode option, which I'll show you in a bit. And just to call out, there's release notes available at this link, and it'll be in chat as well. I see that Jacob just added that, as well as a blog post covering these concepts in a bit higher level. So diving into the particulars of the enhancements. So the first thing on app performance. So on the left, you're seeing what it would have been like in 0.17 to do a search across, in this case, 180,000 objects. So searching for car, app is crunching away, takes a few seconds to load. Whereas on the right, we see the exact same data set, the exact same search happening in 0.18. So that search is almost instantaneous. So in this particular case, it was a 10x improvement in performance in the app. So super excited to bring that to folks out there that are working with larger data sets. And I'll explain how that was enabled in just a second. Related concept I mentioned earlier called sidebar modes. So the sidebar is what we call the part of the tool on the left, where you can filter, you can change what you're visualizing and also filter and toggle visibility on and off for these fields. So that's called the sidebar. And the sidebar now has two different modes of operation. There's a mode called all and a mode called fast. So basically what that's controlling is how many statistics are computed in that sidebar whenever you update your data set or change the view that you're looking at. So for smaller data sets, the default is all mode, where every time you update the view, you'll see all of these numbers immediately populate. So you can see sort of like a full stratification of what's in your current data set or in the current view if you apply the filter. However, if you have a very large data set, the tool will actually default automatically to a new mode called fast mode, where all of these statistics will not be computed by default. You see when I switched to fast on the side there, those numbers disappeared. That's because they're not being computed until you expand the filter tray for one of those individual attributes, in which case only that data is pulled. It's a substantial decrease in the amount of load on the database, and it makes the system load far faster. And in fact, even in so-called all mode itself is also significantly faster in this release as well. So performance enhancements across the board, but key to all of this is that you don't have to change anything about your existing data sets. They will basically default to this third mode called best, which will just choose whether all or fast is more appropriate for your data set based on its size, the type of media, the number of fields, and so on. So the TLDR, no changes needed from you. Your data sets will likely just load far faster in the app. If you prefer to customize how the sidebar is loading, you can change that in the menu that's shown here. That can happen sort of on the fly without you configuring anything. It's also possible, and I'll show it in the code in a second, how you could configure what the default sidebar mode should be for a specific data set, different from this global level setting. That's also possible. Related to sidebar modes is sidebar groups. So what you're seeing on the right over here is a feature that has existed and continues to exist in the app, where you can create new sections or groups in your sidebar to organize the fields of your dataset schema. So for example, there's some default sections, ones where tags are stored and metadata. And then basically other fields are split into whether they're labels, which presents computer vision things that are rendered on the app in the grid, like classifications and detections and so on, or other types of fields, primitive values, int strings, lists, and so on. Those are put into a section called primitives by default. But you can create new sections like you're seeing here. You can drag those sections around. You can drag fields between sections. All of this is possible to sort of organize your sidebar. But now in this release, you can customize all of this through code if you wish. So this is kind of showing what that would look like on the left here. Basically, your data set has a property called app config. And in that app config, you can store a number of things. And new in this release is the ability to define the sidebar groups that you're using. So in this particular case, what has happened is I used a method from the library to basically generate in code what the default grouping algorithm would say to do with this data set. And then I'm just doing some customization. So I pulled out the group called metadata, and I said, actually, I'd like that section to be not expanded by default. I'll show this live in a second, but basically that will have cause the metadata section in the app to not be expanded by default. So if you have a bunch of fields that you prefer to have on your data set, but you rarely use, you might consider collapsing that section by default, so it's not sort of cluttering your display when you work with that data set. I mentioned custom label attributes earlier, so here's a bit more detail on that. It's always been the case that you can add as many fields to your data set as you'd like. So data sets must have a field called file path as an example, as well as a field called tags. But of course, you can add as many label fields to your data set as you'd like. You also could add your own custom attributes to the labels in your data set. So in this case, the ground truth field contains object detections. Those have a label and an ID. It was already possible to add custom attributes such as maybe the area or whether that object is a crowd annotation or not. But what wasn't possible was to see those attributes and filter by them in the app. So that's now possible. It doesn't happen by default. The way that it basically works is you tell FiftyOne that you would like your custom fields to be included in the dataset schema. I'll show how you can do that through code in a second, but basically you have a number of options. You could manually define specific ones by calling add sample field. If you would prefer, you can, when you add new samples to a data set, this would be happening with methods like add samples or from dir. You can pass a new flag called dynamic equals true, which will tell FiftyOne, just declare every custom attribute nested within my samples that you find. Just go ahead and add that to the schema. I want all of those to be filterable in the app. If you have already created a data set, it already has these custom label attributes, and you now just want to add some or all of them to the schema. You can use a couple utility methods that now exist on your data set relating to getting what we call the dynamic schema, all of the fields on your data set that have values but haven't been declared yet. You can see what exists, and then you could also add all of them automatically using this method. Or you could add specific ones using this method here. I'll demo that in a second. But again, the end goal is sort of twofold. When you declare these attributes, it causes FiftyOne to do validation against those fields when you add new data. So if you want to require that all of your samples, their ground truth labels have a field called area and it has a certain type, well, you could declare it on your schema, and then no new samples will be allowed unless they either have a missing value or have a correctly typed value for that field. So that's one benefit, sort of schema management. Optional, of course, because FiftyOne is always very flexible. You don't have to declare things. You can store heterogeneous data if you wish. But if you want to work with things in the app, of course, it does need to have a consistent type. And so declaring those dynamic fields allows that to happen. So more ways to organize your data and make it searchable through code as well as the app. A little more detail about field metadata. So here's a sort of complete example here. I created a data set, in this case, just loading a data set from the zoo. I'm retrieving a field here, the ground truth field, but it could also be one of these custom dynamic attributes that we were just speaking about. Those got added automatically here. I'll show that in a second. But in any case, you can now add a description to your field, as well as store an arbitrary mapping of keys and values in a field called info on those fields, similar to how you can store descriptions and info on data sets. And so now if you save that information, it'll be there so you can retrieve it later through code. But this information is also available in the app now through a new tooltip that appears whenever you hover over a field or an attribute. You'll see the description that you provided. If it's very long, it'll be expandable. If it contains URLs, you can click into them. So reasons this feature might be useful, maybe you have a ground truth field. Those annotations were generated through a specific annotation run on your annotation backend. Maybe you want to link into the task where those were created. Maybe you have a predictions field, and those particular predictions came from a certain hyperparameter run of your model training. Well, you can link into your dashboard, say it's MLflow or weights and biases. You can link into the dashboard through that tooltip, so you can just click in and see more about that model whose predictions you're looking at. And then finally, a fun one, there's a new toggle in the upper right. You can toggle between light and dark mode in the app. I'll show that in a second, but if you are one of those folks that prefers light mode, it's now there. Like I mentioned, it's all open source, so do check it out. And without any further ado, I will check it out for you. I will just fire it up and show you some of the stuff in action. So I've got a shell over here, and I've already imported FiftyOne. I've also already launched the app. I guess I can do it again real quick. So here I'm running v0.18. It's bigger. So I've got v0.18 here. Now let's show some of those features that I was speaking about. Let me grab a piece of code here. So first, here's an example of creating a sample. And this sample has some ground truth object detections in it. And as normal, I need to provide a label and a bounding box for my object detections. But suppose I'm also adding a custom attribute. My animals have a mood. I've always been able to declare those on my sample. So I can continue to do that. I can see that information is there. But now, before now, suppose I wanted to add that sample to a data set. I could already do that. And both now and then, if I were to look at the schema of that data set, I would see that, I have these top level fields. I also have some nested fields of my ground truth field, but I do not see mood. And that's because by default, these dynamic attributes are not added to my dataset schema, but I can add them. So I'll use one of the methods that I mentioned before. When I'm adding samples to datasets, I can pass the dynamic equals true flag. So when I do that, okay, I've now added the same sample again to the dataset. But if I repeat the process and just check and see what's in the schema, I can now see that mood is in there. So now it's in my dataset schema, and that was a choice I made by passing that dynamic equals true flag. So in order to show this to you in the app, let me load up a dataset that has a real dataset. So everyone's familiar with the quick start dataset probably. Let me just load that in the app real quick. So I haven't declared any custom fields, so you've probably seen this data set before. And, if I open up the ground truth filters, I just see ID and label. But if I look at one of the object detections in my data set, so here I'm grabbing the first sample from the data set, and then from the ground truth field, grabbing the first detection. Maybe you've noticed that there actually are additional attributes that are already on this data set. There's an area field. This data came from Coco. So Coco stores the area of the box in pixels, as well as a isCrowd attribute that indicates whether the annotator boxed an individual object, that's isCrowd equals 0, or a group of objects, a crowd of objects, that's isCrowd equals 1, 1.0, for reasons I don't understand. But that's what they used. So let's use one of the other methods that exist in the tool to declare those attributes. So first, let me just run the get dynamic fields method. This method is basically looking at the schema of my data set and finding any undeclared dynamic attributes. So area and isCrowd are undeclared, and it's telling me that they have a type of float. So basically, if I now want to add those to my data set, well, I can use one of the methods that was mentioned before. I can say, you know what, I want to explicitly declare the isCrowd attribute myself. So I can do that. And then if I refresh my session, we'll see that isCrowd is now available. So it's the data is already on my data set. Now I've added it to my schema. So if I want to do a filter, I'm now seeing only the objects that were annotated as crowd. So all of these, if they're correct annotation, should contain one or many of the label. Many persons, many umbrellas, also many persons, and so on. Now, I also had this other attribute is area. So now if I look and see what is in the so-called dynamic schema, isCrowd is not in there anymore because it's already been declared, but there is still this area field. So I could also use the other method. This method will just add all of the dynamic fields. So I can just run that. Okay, now it's added the other one, area. So if I refresh, this time I'll see the areas in there as well. So I could reset the filter. Now I could filter to show really small boxes as an example. So just a taste of what you can do with dynamic attributes. Now, also wanted to show the sidebar modes. So if you remember from the GIF earlier, I now have an option called sidebar mode in the dropdown here. So like I mentioned, it's always by default set to best. So this is what you will now see for all of your data sets when you load them. And if I want to explicitly choose one of the options, I can do so. So this is a small data set. It's already in all mode, so nothing happens if I click all. But if we want to see what would happen for this data set in fast mode, I can click that. So notice that the counts, those disappeared. In this case, they were already computed, so that's helpful. But the point is that if I refresh the page, then well, it actually defaults. So if I refresh the browser, if I refresh here, you see that it's in fast mode. And so none of those counts came in. So this will load even faster. So to show why that might matter, let me load a larger data set. So here's a larger data set I have. This one has 27,000 samples. So it defaulted actually to fast mode. If I wanted to see all the statistics, I can do that. And you see they come in, but they take a bit of time, right? So basically fast mode is a much better option for this data set by default. So this is a behavior that you'll enjoy sort of out of the box for your data sets. I'll load one more here. This data set has 10,000 samples, quite a few label fields and so forth. So, basically loaded instantly. If I do want to see more detail, maybe I want to see what's in the detections field, I can just expand it and those statistics will come in. You see now it's showing the count and now it's giving me the ability to filter by that field. But the key is that the whole experience is just much faster now because it's only sort of computing what you asked it to. And it's allowing you to, get a hold of the underlying data and start looking at it in the grid much faster. Like I mentioned, I can also customize these things through code. So, here I can just make sure I have the right data set and code. This is the quick start data set. I can show what my dataset's app config looks like. So here I haven't configured a sidebar mode. That'll be the default for all of your datasets. But if I would prefer to do that, I can do so. So here I've set the sidebar mode to fast, overriding the default for this dataset only. If I want to take effect, I need to save. So now if I refresh, this dataset will load in fast mode by default. So this is an option available to you. And then, as I mentioned, you can customize the sidebar groups of your data set. So if I want to add a new sidebar field called new and add a field to it, I can do this. Let me just show you that it also comes into the app config. See how that information is in the app config. But I can also modify it through code and have it take effect in the app. So maybe I'll start by clearing it. So I reset, now it's just doing its default thing. That new field I created was gone. But I can go in the opposite direction if I prefer. So let me just put this code in. So here, this was the code I was showing in the slide deck earlier. Let me just create the default sidebar groups for this data set. I'll set the metadata field to non-expanded by default, and then I'll just add a new sidebar group called new. So similar to what I just did, but I'll just do it through code. If I refresh my session, I'll see that. So you see that my data set has an app config, which is saying that the metadata section should be non-expand default. So when I refreshed my browser, that metadata field is collapsed by default. I can open it if I want to, but by default it was collapsed. And then I have this new field, which is, I declared, it has nothing in it yet, but I can add things to it if I need. And then just quickly, I'll show the metadata concept I was talking about. So here, let me define the description and an info field on a couple fields in my data set. Now, if we look at the app again, I have this tooltip that appears that's showing me that metadata that I added to my data set. So for example, on the ground truth field, I have a URL I can click into, taking me to the docs. But also on this area field, I added a description of what is in that field, as well as the same URL. So this support is in the tool. Obviously, this information persists between sessions. So you can now store information on your fields. So with that said, let me take a quick breather and see if there's any questions. If so, I would be happy to answer them. So I see a couple that came through in chat already. And if you have any others, feel free to throw them in as well. So one question was around tutorials or video tutorials specifically. I'm not sure if you're referring to tutorials about working with video data sets, or if you're saying, why doesn't your YouTube channel have more videos in it? I don't know, it doesn't matter which one you were asking about, but definitely the plan is to generate more video content about image data sets and video data sets. So stay tuned. We will be putting out more content, more sort of high-level walkthroughs of the tool, demonstrations of capabilities that exist. So yeah, stay tuned. You can find us on YouTube at Voxel51. See, Tony has an interesting question. So a question around working with video tensors and more generally, where is the data stored when you're working with 51? It's a great question. So, just to clarify, open source 51, it's really designed to be an individual sort of local experience for a user. So when you create a data set, or rather backing up, when you import the library the first time, right? What actually happens is a Mongo database is spun up in the background, and any metadata or samples you create, all that information is stored in the database. And then you're also storing pointers to the media, right? A path to the media, the video on disk, and so on. So that media lives separately. You can work with 51 in all kinds of different environments. Here's a section of the docs on that. You can work with 51 locally. You can work on a VM. You can work in a notebook. You can work in a remote notebook. So there's sections in this section here that kind of cover all those details. So as an example, if you are working with data on a VM, of course, you can just import the library and work with it there. You can pass the remote equals true option when you launch the app, and then it won't try to launch the app on your VM because you just are SSH'd in, as an example. But you can connect to it through port forwarding on your local machine, similar to how you would do with TensorBoard or Jupyter Notebooks and so on. And you could actually see the app, so you could have the experience I was showing here, where this data lives on a VM, right? If you're wondering how do I work with data in the cloud, so that is actually something that our enterprise product, 51 Teams, is meant for. So this is not a talk about Teams, but if you're out there wondering how do I work with data stored in the cloud, well, that's what 51 Teams is for. It's a fully backwards compatible version of 51 that supports things like having your data stored in a central place and having your data lake, your media, stored in cloud buckets. So that's what you need. Feel free to reach out. You can find more on our website about Teams, and of course, reach out in the Slack community. I'm happy to answer you any questions you have about that there. One, maybe more specifically to Tony's question, what about like running inference? So suppose you have a pipeline where you're training and you want to apply inference on whether it's just like inference on images or inference on some video, a fancier model like a video action recognition model. 51 does have a built-in capability for that. If it's of interest to you, it's not a requirement to use, but you could use a method called apply model. So there's actually some documentation coming up soon on the website about how you can basically wrap your own PyTorch model as a model instance in 51, and then just pass it to this method, along with some configuration around batch size and number of workers for your data loader and so on. You can actually ask 51 to do inference. It's not a requirement. You don't have to do that. Another, the more standard way to do that would just be to write your own loop. So 51 is really just a way to store the model predictions. So it works in concert with your existing training loops. So if I click, for example, into a tutorial about Detectron 2, just as a point of reference, what you'll basically see is that you run inference as normal. You train as normal. Maybe you're using TensorBoard or something else. Basically, what you just need to do is add to your inference loop some code that extracts the model's predictions and stores them in the appropriate 51 types and just adds them to your data set. Here's a nice clean way to do that, to add a slice of predictions to an entire data set. But basically, inference happens on the machine where, more machines, plural, where you are doing inference, and then basically you just need to import 51 and load the right data set and add your data to that data set. There was a question about ActivityNet. So let me just quickly click into something. So there's a part of the tool called the dataset zoo, right? So in the zoo are a number of common datasets. In many cases, if you were to go to the source of the dataset, maybe Coco as an example, you'll actually see that the Coco authors are recommending to download and work with their dataset through 51. So just show that download. So 51 is a very convenient way to download a data set or maybe a specific subset of it. In this case, 50 samples that contain persons or cars, these task types. So the dataset zoo is a useful way to do that. And ActivityNet is in here as well. So if I click into ActivityNet here, you see there's all kinds of options for loading a specific split of the data set, or only certain classes, or only videos of a certain duration, and so forth. So here's a little snippet that would show what it would look like to load 10 samples from the validation split. Here's a little snippet of what that data set looks like in 51. But this is a video data set, a video classification data set. So what you'll find is videos that you can thumb over, and then the classifications that exist. So I think I'm close to about out of time. Maybe I should hand it back over to Jimmy to bring it home.
That'll work. In the meantime, you can kind of work on, there are 5 open questions in the Q&A, so high time to take a look at those and either answer them live if you want to take that opportunity now, or you type out the answers, your choice.
I missed these. I was looking at the answered questions. So you got 2 answers. Lucky folks in that section. So let me just quickly answer the open ones. Let's see. Video frame by frame annotations. There in 51, we have some integrations with things like CVAT and so on. Maybe I'll just show quickly. So we have an integration with CVAT because it's open source and it's great, but also other ones, Label Studio also open source, other ones like Labelbox and so on. Video annotations, and in particular frame by frame video annotation is supported. So you can send a video data set up for annotation using this integration, pull back in frame by frame annotations. There's actually an interesting discussion in Slack going on about this a while back. Often for video annotations, you don't annotate every frame, you just annotate keyframes. Those keyframe information are pulled back into 51, and if you want, you have access to whether or not an annotation is a keyframe annotation or whether it was an interpolated value. So 51 will sort of automatically interpolate those frame annotations, but it'll also tell you the ones that were keyframes. So if you need to retrieve the the human annotated frames, you can do so. It's actually, I think, in this section here about annotating videos. So take a look at that. Question about whether changes in the app config are also exported. In general, there's lots of ways to export in 51. They're all documented in this section here. If you want things like dataset level metadata and so on to be exported, then obviously Coco format has no notion of 51 specific things. It just knows about one field's worth of annotations. But if you export in 51 dataset format, everything, including all of the customizations I just said, like field metadata and app config settings, that's all included. So if you export in this format and then pull it back in, yes, it will be included. Question about video clustering, super interesting. So the part of the tool where you work with embeddings, that's the brain. So, what you'll find in this section of the docs I'm showing here is some examples of working with embedding methods. If you want to work with video embeddings, you will need to use the choose your own adventure option in 51, where you compute your own embeddings. So there is actually, I was mentioning earlier that it's possible to provide a model to wrap your own model in 51's interface. And there is an interface video embeddings models, but basically the choice of how you want to generate an embedding for a video is up to you. If you think that the right way to do it is to embed every 10th frame and then average the embeddings or concatenate the embeddings, you can do that. If you want to use some other model, like an activity recognition model, and pull some embeddings from it, you can do so. But basically, once you've computed some embeddings, you can pass them to the relevant methods downstream in 51, and you can have your clustering workflows for video models. But the choice of what the video embedding means to you is something that you'd have to choose, because it's not necessarily, there's no right answer there. It depends on what you're trying to optimize for. Question around, can datasets be corrected on the go? Yes. So everything about 51 is mutable. So, just to highlight some things, once you've loaded in a data set, you can edit things in the app. For example, if I found some samples that I don't like, I can tag them. So, in that sense, you can edit through the app. You can find or exclude those samples through the app. Of course, those changes are persisted to the underlying data set. So if I count the sample tags on that data set, we say I have these 2 with bad sample. So yeah, you can always be editing your data sets completely programmatically. Some support for editing in the form of tagging exists in the app. Of course, you can send data for annotation or add or remove new fields at any time. Just to call out quickly on the how would I edit annotations workflow? 2 answers to that one. One, all of those annotation integrations, they support uploading existing data. So this example here is showing it. If I have a data set and I want to change the ground truth labels, this is what this command is telling to do. You can just send the ground truth labels in this view up to the annotation backend. And then when you import the results, those changes will be made in place. So that's one way to edit. One other thing to call out, actually many parts of 51 are actually pluggable. So to take a quick example, I have a data set in here somewhere, I think, which has geolocation data. So this one has a field called location that has GeoJSON data. So I can open up a map and I can view that information. But moreover, actually this part of the tool, these tabs are actually, they are pluggable. So there's a plugin API whereby you could write your own plugin to render your own custom visualization of your data set. There's a whole API that in the documentation. I'll just search for that real quick. Custom plugins. So there's a whole documentation page on this, which I'll put in the chat. Sorry, so I'll put that in chat. So this is information about how to write your own custom plugins. But not only can you plug in this area of the code, you could also plug in your own visualizer. And so it would actually be possible and would be amazing if anybody was interested in writing a plugin that would just embed the annotation tool into the app, because then you could directly edit in 51 if that was of interest. So already possible through plugins.